Hello, we are going to present our project on free fall. So the objective of the project was to show how two objects fall right at the same time, and we wanted to show some equations that we found very useful in order to find that both objects are going to fall at the same time. And here's our work. This is Cassandra. You're going to see the video. And she has two different balls. One is made of paper and the other one is made of clay. And both have different masses. She released them at the same time and they both strike the ground right at the same instant. So first we would like to find out what the final velocity the balls had. So we're going to put together a series of equations to show that. First, we wanted to use the equation of the final velocity squared is equal to the initial velocity squared plus 2 times the gravity times the distance.
And we have the initial velocity 0 and
we have that the gravity is 9.8 meters over second squared. We also know that the distance is 2 meters, and that's all we
want to know
the final velocity
and the time.
We would like to know the time. But first, we're going to solve for this equation. So we don't know what the final velocity is going to be, so we're just going to
initial 0.
And this is squared plus 2 times 9.8, which is a gravity, and then we have the distance, which is 2 meters. So we did the equation, and it turns out that it's going to be 39.2. Because that's a result of this multiplication because the zeros are cancelled. Then you have the final velocity is going to be the square root of 39.2. And finally, we have the final velocity is 6.26 meters per second. 26. Okay. So now we have the final velocity, but we still need to know what the time is going to be. So we're going to first write down our results and then just erase what we have and keep moving on with the next equation. Right now we have this much data and we need to find out about the time. So we think it's very appropriate to use the formula up here because it has the final velocity, which we just found, the initial velocity, the gravity, and the time, which is what we want to get. So we take the original formula, we write it down, and then when we clear it off, it turns out that time is equal to the final velocity minus the initial velocity over gravity. So time is the initial velocity, final velocity minus the initial velocity. That's right, 9.8 as the gravity. And if we solve for that, we have... No, porque aquí estaba de este lado. Y entonces...
Y aquí es negativo y se cancela el negativo. Y ya lo que te da.
¿Cómo que se cancela el negativo?
Mira, de todas formas al menos va a salir lo mismo. Tiempo es igual a...
Dice que vamos a editar estas partes.
Sí, lo corto.
Ok, tiempo,
Estamos mal en la... si es menos 9.8.
Pero te habrá salido un número imaginario.
No, pero se borra. Se borra el negativo.
Sí, bueno, es lo mismo.
y sigue saliendo lo mismo. Entonces, ¿ya cuánto es?
Punto 63.
Y ya, sale lo mismo.
Entonces ya. Le continuamos el video, lo paramos y lo volvemos a hacer.
No,
Lo
así.
continuamos, ¿no?
Ajá, y ya.
So, we have that the time when we clear out this equation is 0.63 seconds. And now we have all the information that we wanted. And next we're going to show you the videos of us releasing the different objects to show that they strike the ground at the same time.